there are accelerators in nature which are something like 100,000 times more powerful than something we can build on Earth. And these are the properties of astrophysical objects. And maybe by studying the cosmic rays they produce, we can understand a little better the mechanism of how these astrophysical accelerators actually work. Cosmic rays, the beauty of them is when they land on Earth, the atmosphere is a filter, so you're basically left with one single kind of particle, which is called a muon, and it doesn't interact very strongly, so one can easily get scintillation counters, count them, stack up the scintillation counters, and see the rate, see how they are peaked at the vertical and they fall off, I think it's cosine squared theta as you go off to the side. You can also use this to learn something about how to detect particles, photomultipliers, multi-wire chambers and everything, because this is a technology which has such broad application. For example, go to any hospital and you have many, many people who know how to detect radiation, all the way from X-rays, you have proton accelerators for cancer treatment and all of this. So it gives, in a very simple way, students the opportunity to observe the way you detect particles. I think this is, in some sense, the most important aspect of that. Well, I think that's probably disappointing. I didn't have, as far as I know, a role model other than a very strong high school teacher. This, we're talking about junior and senior year in high school, and we have a marvelous teacher. So I think that got me interested in science. But I never deviated. I did my studies in undergraduate. I majored in physics, and I loved it, so I went to graduate school, and I was lucky enough to succeed to some extent, at least in research. But I think this is a marvelous program, and I certainly wish you all the luck in getting it going.